Right, so next job is to check out the driver board. Now, looks like the owner's done quite a bit of work again. They've replaced all the header pins. These sockets are as well new, I think. Let's have a look. Yeah, contacts look pretty decent in those. We've got some turn pin sockets. Again, I think the owner's done some work on this. I'm not sure about those solderers. Let me just get a closer view. Okay, yeah, that's not looking great there. We can see some of those pins aren't actually touching the solder joints. I don't know if you can see those, but basically that one there, 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 that one there. So I think I better do some reflowing of those joints before we go any further. Now, I'm not sure how well you'll be able to see this, but I started reflowing these joints and the joints went cloudy as I was doing it. It indicates it's probably got lead-free solder on there. So what I'm actually going to do is I'm actually going to desolder this socket entirely and refit it with leaded solder. It certainly doesn't look like it's fitted well enough to use anyway. There's too many pins there that are not actually touching the pads on the top side. I was really struggling to melt that solder, and I've got a high temperature tip in my desoldering iron, and I use the high end stuff here. So yeah, that solder did not flow well at all, and it's left a lot of residue on the top. So I'm going to clean up the top side as well. I'm going to polish that up with a fiberglass pen to get a nice finish, so that the new solder will stick to it better. Still need to do this bottom side, obviously, and then I'll put a new socket in. That definitely needed doing. Half those joints were terrible. Now, one thing I like to do when the pads haven't got good adhesion is to basically put some fresh solder on the top and then desolder that again. That's basically tin plating all this top side. That'll make the solder flow through better when I resolder the socket in place. Right, so I've fit the new socket, and if we take a close look at the solder joints from the top, we can see that every single pin is touching the top pad and has a nice bead of solder at the top. So that's how it should be. I think this one here is probably going to want doing as well. As we can see, look, we've got lots of the pins where they're basically sort of just floating above the pads. So yeah, I'll have to desolder this one as well. It's just, even if it is working, it's just not going to be reliable like that. So those will easily crack. And there we go again. I'm just showing you a close-up of the soldering on the second PIA. That's now been replaced, and the solder joints are all looking good. Okay, now that we've got good connections to the PIAs, I've basically just been through and tested the outputs of every one of them, so they're all working fine now. The next thing to do is basically go through systematically and test the switch inputs, test the solenoid, the lamps, test the solenoid drives, the special solenoids. This takes a bit of time because I need to go through and test every single output, triggering the inputs, and making sure the transistors are good. So up to the PIAs, we're now good. We don't know if we're good past these logic chips yet. Okay, so while testing, I found a short on lamp row number 3. That one is stuck low, so possibly a shorty transistor, but we'll check it out and see where the fault actually lies. Okay, so I've resolved the lamp row issue. So it was the MPSA 14 and the 2N5060 SCR for column number 3. So if we just check that out now, 1, 2, 3. See that's now pulsing again. So that's that one fixed. Well, the solenoid section tested out fine, however the special solenoid section does not. So I'm just part way through the test, and basically 4 out of the 6 special solenoids are just firing on their own. So you'd have, pop bumpers and slingshots going off on their own, possibly locking on, because I think either the inputs are floating, causing the outputs to trigger, or the transistor just potentially shorted. This is the input section here, and this is the output section. I'm just going to trace back and find out why these are firing on their own. Well, I found one of the problems with the switch solenoids, and that is that pin 19 of this PIA is floating, and that should actually be the enable line effectively for these. And what it is, that floating line is going into the buffer, and well, it's not a buffer, I think it's an inverter, is it? I can't remember off the top of my head. And basically the float is being picked up as a high signal, which is then inverting to a low, and that low is being permanently enabled. So we have to replace this PIA and see if that fixes that problem. Okay, so I fitted a new IC5 PIA here, and pin 19 is no longer floating, it's now pulsing as it should be. I'll check the rest of the circuit. Okay, and IC7 appears to have a bad output at pin 6, that is stuck low. So we need to check if it's actually the output of this chip or if it's the input of the next chip in line, which is IC9. IC9 is that one there. So we need to take one of these out and then check if the low condition still exists. Remove the 7402 at IC9 and the output basically of IC7 is working again, so it seems like the inputs are shorted. So let's give this a quick test, and that's a fail, so that's a dead 7402. We've made some progress now to fit in the new IC9. We can see that the enable 9 is now being toggled, but the output, let's get the pin on there, the output is still low, so something on the output side is still shorted on some of these switch transistors, as I believe they're still pulsing when they shouldn't be. Can't see that very well. Sorry there, yeah, you can't really see it, but it is pulsing, but it's actually pulsing shorter than before. So we're improving things, but we've still got something wrong on the output side, so we need to check that out. Well, I found the pre-drive transistor on drive number 5 here, which is a 2N4401. That was bad.